hear me clearly? Okay. I want to welcome everyone to my lecture today. Today, I'm actually going to walk you through another exciting topic in statistics. Of course, I told you the other time, statistics is like a story, okay? A story that goes on and on and on and on. We're actually going to focus on two lecture materials today. And of course, the first one is about estimating population variances. Okay, how do we estimate population variance in one population? And the second material is actually going to be how do we estimate population variances in two populations? Okay, maybe we want to compare population variances. Now, let me tell you this. We find ourselves in a world where we estimate. Okay, I'm going to say that again. We find ourselves in a world where we estimate. And why do we estimate? Is because we don't carry out what I call total investigation, where we actually going to investigate all items in the population. What we normally do most of the time is to take sample. When you take sample, then you are estimating. Okay, the population parameter could be mean, population mean, it could be population proportion, it could be population variance, or population standard deviation. Of course, before now, I think I've walked you through how to estimate the population mean. We did that for one group. We also did that for two groups. And I also walk you through how to estimate the population proportion. We did that for one group. We also do that for two groups. But the focus today is basically going to be on how do we estimate population variance or the population standard deviation? And how do we also construct an interval for that? And not only that, how do we decide on the number of samples to be taken from the population if we want to estimate the population variance or standard deviation? That is a focus today. Okay. Like I said, it is not all the time that our interest may be on average. Do you know that our interest may actually be on consistency? You know, when you look at, in industry where they're into production, even if they're using the same machine, we expect a variation in what they are producing, because there's always what I call a natural variation that is inherent on any activity. Before a particular industry go into production, I know they have specification. And the reason, they have inspectors, they have quality inspectors on ground that will actually investigate whether what they produce conform to what was initially specified. Now, in that kind of situation, and we find ourselves in a stochastic world where we cannot rule out variation. There's always going to be variation in quality, okay, in what we produce. And that is the reason why we actually need to investigate the variance. If we want to talk about variability, then you need to estimate what is your variance. Okay, and that was why I said, for an example, an auto part manufacturer must test to ensure that each auto part that comes off the assembly line matches the necessary specifications. Before you go into production, of course, I know you have a specification, and at the end of the day, you need to be able to investigate whether what you produce actually conform to specified standard. Okay. And that was why I said the consistency of quality in the auto part is very, very essential. And the only way to do that is we need to have a way to estimate the population variance or the population standard deviation. Now, we're going to be working with some notations now. When you say sigma squared, that is a population variance When you see S squared, that is a sample variance. You know, the quality inspector does not need to investigate all item produced. We don't carry out 100% inspection. They're only going to take sample, right? You know that they're going to take a sample. And you know what? Instead of them to calculate the population variance, they're only going to end up getting the sample variance. But you know what? It is mathematically proved and statistically observed that the sample variance is an unbiased estimate of population variance. So what I'm trying to say, if we follow the procedure, provided that the sample that we actually examine is chosen randomly from the population, then the the sample variance will actually be good. You know, we can actually use that to represent the population variance. And similarly, we can also use sample standard deviation to represent the population standard deviation. Okay, I want to walk you through this example now. A general auto is testing the variance in the length of its wide-shed wiper blades, and a sample of 12 wide-shed wiper blade is randomly selected, and the following lengths are measured in inches. Take a look at this. Oh my God, there's a variation here because you can see the values are not the same. We can only have variation in a stochastic world. We live in a stochastic world. Even if we're using the same machine is actually going to bring out different inputs. I mean, different outputs, values. Take a look at that. Okay. What we now want to do now, if all of these values are the same, then the variance will be equal to 0. That is if you all have the same value, but that is not possible in a stochastic world, in a probabilistic world. Because the reason why we actually want to find probability is because probability thrives in variation. If there is no variation, we don't talk about probability because there is nothing to manipulate. Okay, now you want to find, they ask you to find the point estimate for the population standard deviation, or you want to find the point estimate of the of the population variance. Of course, you can actually use whatever method, whether you want to use the software or you want to use a manual way to find the population, to find the variance or standard deviation. Then, so when you do that, whether you use your calculator, and let me tell you, if you want to go by manual, it's going to be summation x minus x bar all squared divided by n minus 1 for the sample variance. And of course, when you find the square root of that, that would be the standard deviation. But you know what? You can use your calculator to do that. You can also use software to do that. Now, what I'm trying to tell you now, the standard deviation is that, okay? And of course, the variance is just going to be the square of the standard deviation. And of course, you know, the standard deviation is the square root of the variance. They share relationship. Okay, this, what I have here is actually because we have a single value. That's a point estimate. And you know, a point estimate could be wrong or right. I think I justified the reason why we have to go from point estimate to interval estimate. Okay, because a point estimate, I give a single value could be wrong or right, and we don't want to waste our time, you know, where we've committed a lot of resources to research only to be wrong at the end of the day. We don't want that. And to be at the safer side, we actually need to have a way to construct the interval estimate. Okay, we did the same when we're talking about mean and proportion, and we're also going to do the same when we're talking about variance and standard deviation. Now, let me tell you this. If you want to construct an interval estimate for variance or standard deviation, we need assumptions. Of course, you know, even in the other one that we've done before, I also walk you through assumptions. And assumption number 1 here is that the sample that you are choosing from the population, you got to choose that sample giving equal chance to every other item in the target population, okay, which means you have to choose the sample randomly. Okay, now that is number one. And number two, the population you are choosing from, the population you are choosing your sample from has to be normal. We got a way to investigate that, when you try to get the histogram. Okay, the histogram plots, you'll be able to see whether the population is normal or not. But you know what? If the population is not normal, there's no problem. They provided the central limit theorem apply, you choose a sample size that is 30 or more. Okay, now the last assumption. Now, after that, the next thing that we're going to do now is this, and I want you to pay attention when we're dealing with the variance. When we want to construct an interval estimate for the variance, oh my God, we don't talk about the margin of error. Okay, go ahead. Yeah, that's a very good question. You are trying to say they ask us to get the point estimate of the population standard deviation, but I find the sample standard deviation. I say that the sample standard deviation is an estimate of the population standard deviation. The sample variance is an estimate of the population variance. Do you understand that? Yeah, that is the reason. That's a very good question. Okay. When we're dealing with the estimating the population mean and a population proportion, we use in the margin of error, we have a z-score, we have a t-score, depending on whether the population standard deviation is known. But you know what? When we want to construct an interval estimate for the variance, we don't need t-score, we don't need z-score, but we actually need chi-square distribution. Chi-square. We're going to have an entirely new table, which we call, the distribution is going to be chi-squared. And of course, for us to check from a chi-square table, we're actually going to be checking from the degree of freedom against the level of confidence or level of significance. The degree of freedom, of course, is going to be n-1. And this is the shape of the chi-square. Okay, and I'm going to show you the table of the chi-square now. Take a look at this. Okay, let me use this opportunity to tell you your final exam. You don't need cheat sheet in the final exam. Your final exam is going to be an open book. Okay, your final exam is going to be an open book. I just wanted to know that. So, of course, in an open book, you have access to whatever you want to check from. Take a look at this table now. This is a chi-square table. This table is different from a t table, and it's different from a z table. This is a chi-square table. Okay, yeah, go ahead. Yeah, you know what I'm going to do? I'm going to ask you, depending on what you want to use in the exam, yeah, okay, you bring, since it's an open book, you bring everything. You get what I mean? Open book means bring your statistical table, bring your notes. The only thing you are not going to do is to search for something online. Okay. And you know what? On that day, for those of you that may find it difficult getting statistical table, I'm also going to come to the exam. I'm going to bring all the statistical table you need. If you are interested in that, you just request for that. Does that make sense? Okay. Now, what am I checking here? I'm checking under the degree of freedom 5, okay, against 95. Look at that, 95% confident. Now they give me 1.145. Okay, now let me quickly go to an example and you're going to see. Now take a look at this. I want you to pay attention to this now. When we were constructing the interval estimate for population mean and for population proportion, you know what we normally do, right? We normally find the margin of error, right? We subtract the margin of error, right? From the point estimate, we add the margin of error to the point estimate. We don't do that when we talk about variance. Now, when you take a look at the formula I'm showing you now, this formula automatically gives you the lower end point and the upper end point. Take a look at that. Now, what is the difference between the lower end point and the upper end point? Oh my God, the numerator is the same, right? The denominator is not the same. If you look at the first denominator here, we're going to check this from table alpha over 2, but that one 1 minus alpha over 2. Look at that. That is the difference between them. Okay. Now I'm going to walk you through an example now. Now, I've already shown you the one for the interval estimate of the variance, the formula to use. I'm also going to show you the one that has to do with the interval estimate for the standard deviation. Oh my God, what am I doing here? This is just the square root of the other one. Look at that. It's just the square root of the other one. It's the same. Look at that. Okay. The next thing I'm going to do now, I'm going to quickly take you to an example, and you're actually going to see. Okay. In the example now, a commercial bakery is testing the variance in the weight of the cookies it produces. We don't want, the bakery don't want a situation whereby the consumer will not get value for their money. At time when you take a look at cookies we buy, okay, you're going to see that, some actually have more weight than others. And of course, that is the reason why in every industries like that, they need to have a quality inspection officer that will make sure that there's a consistency. If we want to measure consistency, we need to estimate variance or standard deviation. That is what we use to measure consistency. And that is the reason why we actually need to estimate the population variance. Now, take a look at this. A random sample of 15 cookies is chosen. Of course, a quality control officer will not carry out 100% inspection. They're only going to take a sample. Now here they're taking a sample of 15 cookies, but mind you, they're taking that randomly. They give equal chance to all the cookies. Okay, the weight of the cookies are measured in gram and found to have a variance of 3.4. They've already computed the variance. Build a 95% confidence interval for the variance of the weight of all cookies produced by the company. What am I going to do? What I'm actually going to do, the point estimate of the variance is 3.4. That has already been given. And if that is given, then the next thing I'm actually going to do now is to get the interval estimate. And to get the interval estimate, then I need to go to chi-square table. In one chi-square table, there is alpha over 2, right? In another chi-square, there is 1 minus alpha over 2. Now, because they're talking about confidence, 95% confidence, if I want to get my alpha, is going to be 1 minus the level of confidence, and that is why we have a 0.9, 1 minus 0.95, that will give us 0.05. Then you're going to do 0.05 divided by 2, that will give you 0.025. Then you're going to do 1 minus that, you have a 0.975. And let me tell you this, when I go into the chi-square table, I'm going to check for 2 values. One, I'm going to check the one at 0.025 with the degree of freedom. And I'm also going to check the one for 0.975 with the same degree of freedom. And you know what? Because the sample size in the investigation was 15, of course, the degree of freedom is going to be 14. Now, if that is 14, then I'm going to go to the chi-square table now. Take a look at the chi-square table now. Under 14 degree of freedom, okay, I'm going to check under 0.975, and I'm going to check under 0.025. Look at that. I got 2 values. I want to tell you the bigger one, the bigger of the values, okay, we serve as the denominator in the lower parts. Okay, and the smaller of the values will serve as the denominator in the upper part of the interval. Okay, now since I got that, now I'm going to go to the interval. Oh my God, what am I doing now? I'm just plugging in the values. I told you, take a look at the lower part of the interval. The bigger value is going to be there. The upper part of the interval, you have the smaller value. They all have the same numerator. And at the end of the day, my conclusion is that the variance, the true population variance, will lie between 1.8 and 8.5. Okay, and if I want to write it, I can put it this way. And finally, I'm going to make an interpretation I'm going to say, oh, the bakery estimates with 95% that the variance in the weight of their cookies is between 1.85 and 8.5. That really makes more sense than presenting a point estimate of the variance. That could be wrong or right. Okay. If that is taken, I'm actually going to go into another example now, but this time around, the other time we talk about variance, right? The interval of the variance. But the next example now is the interval of the standard deviation. But you know what? What we just need to do, since we have already, since it's the same question, this is the interval of the variance, right? If I want to get the interval of the standard deviation, I'm going to find the square root of all of that. The square root of 1.8, the square root of sigma squared, the square root of 8.5, and I'm going to show you what you're actually going to have. Take a look at that, put in the square root of all of that, that gives me this. That is basically what you're going to do. It is the same approach where you are seeking to construct an interval estimate for both the variance and the standard deviation, only that in standard deviation, you're going to put a square root. Okay. And of course, this is going to be your conclusion. Okay. Now, I put a lot of example. You're going to follow the same way. Okay, I put a lot of example. You follow the same way, you're going to get, you're going to get that. So the same. But there is one particular example that I want to mention. What of in a situation where you find the degree of freedom and your degree of freedom is not in the table? I'm going to give you this example now. Take a look at that. Let's consider again the scenario of the seed company given in example 8.27. A new random sample of 86 tomatoes is taken from hybrid and a plant and found to have a standard deviation of that. You are asked to construct a 99% confidence interval. Now take a look at that 86. If I find the degree of freedom, 86 minus 1, that would basically give me 85. When I go to statistical table, oh my God, there is no 85 in this table. I needed to look at the table now, no 85. And how do I check that? Then I'm going to look at the middle of two numbers where that 85 lies. 85 lies between 80 and 90. Take a look at that. Then it means I'm actually going to check under the 80. I'm going to check for the two values. And under the 90, I'm going to check for the two values. But you know what I'm going to do to the two values here? I'm going to find the average. Okay, that is what I'm doing here. Look at that. That's what I'm doing here. You add them together, you divide by 2. Okay, go ahead. Oh, okay. What if it is equal 83? That's a very good question. Let me go back and say, if it is equal 83, yeah, you're still going to find the average. Or at times, some statistician would prefer if it is 83, they will just use 80. Okay, some they just use 80. But you know what? For the purpose of exam, I'm actually going to give you the one that you can locate in the table if you want to make use of the table. Okay. Now, that's it to that. And for the sound, of course, for the sound deviation, you can actually see that. Okay. Now, the next title that I want to talk about is this. You remember where we were dealing with the population mean and we're dealing with the population proportion. I think we decided on how to choose sample size for us to be able to estimate the population mean. But now, how do we decide on the sample size? If we want to estimate either the population variance or the population standard deviation, if you look at the example we did the other time about when the bakery was looking at the weight of the cookies, how do they decide on the numbers of cookies to be chosen from the population of cookies if they want to estimate either the population variance or the population standard deviation? Because we don't just choose sample size. But you know what the good news, oh my God, the good news is that we have a table for that. We have a table for that. Now, what you're going to consider is this. You need to look at what is sample variance. If you look at the first column, the sample variance is within the percentage of the population variance. If for 1% means 99% level of confidence. If you actually anticipating 99% level of confidence, oh my God, you actually gonna choose a lot of sample size. That is why the sample size for 95, for 95, if it's a 1%, when the sample variance is 1% of the population variance, because let me tell you this, we don't expect the sample variance to be the same as the population variance, but we're trying to talk about the distance. If you want to tolerate a distance that would be within 1%, okay, and the level of confidence is 95%, okay, it means the sample that you need is 77,209. If the level of confidence is 99, you'll be needing 133,450 sample. Now, if you take a look at if that is going down, is going up, okay, you're actually going to say that the minimum sample size to choose is going to be going down. Look at that. So we don't just choose sample size arbitrarily. We got a guide. We got a method. We got a formula that we need to. So that is the table for that. This is for the variance. If I want to estimate variance. But if I want to estimate the standard deviation, we also have a formula too to determine the sample size. So take a look at that. If I want my sample standard deviation to be within 1% of the population standard deviation, okay, and at 95% level of confidence, then I need 19,206 sample. And at 99, I need 33,220. And what I just want you to see here is that as the level of confidence is increasing from 95 to 99, then the sample size also go up. That is what I wanted to see. Okay, I'm going to walk you through an example now. Take a look at this. A market researcher wants to estimate the standard deviation of home prices in a metropolitan area in the Northeast. She needs to be 99% confident that a sample standard deviation is within 5% of the true population standard deviation. Oh my God, 99%, okay, is actually going to need a lot of sample. Okay, now assuming that the home prices in that area are normally distributed, what is the minimum number of home prices she must acquire? And I want to tell you, all what I just need to go to the table. This is a table for the minimum sample size for the variance, for the standard deviation. Okay, because we're talking about the standard deviation, you look at the 5%, at 99% level of confidence, she actually need to consider 1,337 homes. But for 95%, she only needed 769. And that was why I made a conclusion. I said, therefore, the market researcher must include at least 1,337 home prices in order for a study to have the level of precision she's anticipating. This is the end of lecture 1 for today. Is there anyone who want to ask a question? Before I go to lecture 2, lecture 1 only focus on one population, and we deal with the population variance and the population standard deviation. I think I walk you through how to estimate the population variance and the population standard deviation and how to construct an interval. Everybody good, right? Okay. But you know what? Do not hide your feelings. You don't understand, please ask me question because you pay for the service. Okay. I'm gonna give me 1 second. I think I have a chat that come. Oh, say thank you. Okay, thank you too. Okay, I'm gonna stop the share now, and I'm gonna go to the next slide, to the next lecture. Or give me 1 second. Okay. Now, the second lecture of the day, we have two populations and we want to compare variances, just like what we did the other time when we're comparing means. We're comparing proportions, but right now, we are actually comparing variances. Or you want to compare the standard deviation. Before I start this topic, I want to tell you this. In algebra, because let me tell you this, in